All right, now in question number 2, again, we're given forces, we're getting charges in a triangular relationship. So go ahead and enter in your name, and our job is to find the magnitude and direction of the net force specifically on charge 3. Okay. Well, this is my arrangement, okay? Take a moment to copy down your arrangement on your graph. Okay, so now step 2, we want to find the force F13, okay, which is the force of charge 1 pushing or pulling charge 3. So let's take a look at this. This was charge 3, by the way. For me, anyway. Let's see what your arrangement is. Make sure you draw your arrangement. So for me, okay, charge 1 is pulling charge 3 this way because you can see they're opposite in sign. So I'm going to make a picture of that. Okay, and I'm going to make a picture over here showing what's going on. So for me, this is force 1-3 going to the left. All right, and I got to find that particular force. Okay, and it's going to the left. In this case, you can see from my picture. Okay, but I got to find it. So F13 is going to be K Q1 Q3 over R squared. That's going to be 9 times 10 to the 9 times Q1 for me is going to be 664 times 10 to the negative 9. Because remember, we don't put the negatives in. And Q3 is, for me, 696 times 10 to the negative 9. All right, now I do have to count up the squares and see how far they are apart. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, let me see, I miscounted. So that would be 10. That would be 20, 21, 22. Okay, so 22 boxes apart would be a distance of 2.2. All right, and then same thing here. This would be a distance of 5, 10, 15, 16 boxes. So that would be a distance of 1.6 centimeters. It is centimeters. Yes, it is centimeters. Okay, so my distance between 1 and 3 would be 2.2 centimeters or 0.022 meters. And I got to square that. So this is F13. Let's find that. So we're going to go 99 times 664 e negative 9 times 696 e negative 9 divided by 0.022 quantity squared. Okay, so I'm getting about 8.59 newtons of force for F13. Okay, now I got to find F23. Now, charge 2 is positive for me, charge 3 is positive for me. So for me, charge 2 is going to push charge 3 downward this way. So I'm going to draw F23 that way. If I complete the parallelogram, that tells me my net force is going to be pointing in that direction right there. And that is going to be my direction, my angle theta right there. Okay, so now I got to find F23. And Yes, it's pointing down. K Q2 Q3 over R squared is going to be 9 times 10 to the 9 times Q2. Now for me, Q2 is 313 nanocoulombs. Enter in yours. For me, Q3 is 696 nanocoulombs. Enter in yours. And for me, it is a distance of 1.6 centimeters, which would be 0.016 meters squared. Okay, so please go ahead and take a second to find yours while I find mine. And for me, I'm getting a value of about 7.66 newtons. Okay, so what I'm going to do is I'm going to draw them. Now, keep in mind, remember, these magnitudes are positive, okay? But if I look at my thing here, F13 is pointing to the left, F23 is pointing down. So just keep that in mind when you draw your vectors down here. So I'm going to go about 8.5 this way, like this. And then I'm going to draw a vector 7.66. That's a little bit less than that. Just a little bit less than that. Going down. So this would be F13. This would be F23. And the resultant vector, net force F, you can see is going to be that straight line right in the middle. That's going to be my net force. And then I got to find my direction, which would be my angle. Okay. All right, so to find the net force, just use Pythagorean theorem. It's going to be the square root of F13 squared plus F23 squared. Well, for me, that's going to be 8.59 squared plus 7.66 squared. Go ahead and take a moment to enter in your data. I'm getting about 11.5 newtons of total force acting on charge 3 from both of those two charges, the direction of which, I'll use the arctan equation. Now, since both of my forces are technically pointing left and down, then I need to apply both of them as negative. So it's my negative y component, so negative 7.66, over my negative x component, which is negative 8.59. And my theta is going to approximately be, go ahead and enter yours, of course. Now for me, I'm getting about 41.7 degrees, okay? Now remember, this is going counterclockwise, so I am getting a positive angle. But what I want to do, guys, is I want to take my angle from 0. So I got to add this black angle to 180 to get what I want. So just, in my case, add to 180. Just take your angle from 0. Figure out how to take your angle from 0 degrees. So for me, I'm getting about 221.7. Okay, I'm going to enter in my values. Go ahead and enter in yours. And there you go. I was able to do that correctly. Hopefully you were able to do that correctly as well.